3.5 scale and scale factor. So a scale drawing is when you make a drawing of something that's an actual thing, and the dimensions in the drawing are proportional to the dimensions in real life. So in this case, we have Haley makes a scale drawing of her bedroom and uses a scale of 1 centimeter equal to 2 feet. What that means is that for every centimeter on her drawing, that's equal to 2 feet in real life. So that is a ratio where we're taking the drawing and comparing it to the real life dimensions. And I have a ratio of 1 centimeter equals 2 feet. And I'm going to use my proportions to set up one where I have my bed is 6 centimeters long, and I want to know what the real dimensions are. So the drawing is 6 centimeters, the real dimensions are my x. I'm going to use my cross products here. And I have 1 times x equals 2 times 6. X equals 12 feet long. A Florida map has a scale of 1 inch to approximately 22.8 miles. So again, I have the map versus the real life. And the scale I have, and this is what I'm going to go by even though it says approximately, is 1 to 22.8. If the distance between Vero Beach and Boynton Beach is 3.5 inches, I want to know what the actual distance is between those two beaches. So the drawing, or the map, has 3.5, and I want to know what this x is right here. So I'm going to use my cross products, and I'm going to have 1 times x equals 22.8 times 3.5. I'm going to do that multiplication here on the side. So when I go back here, I have 1 times x, which is x equals 79.8 miles between those two beaches. This next example says the Sears Tower is 1,450 feet tall. Jeff wanted to make a scaled model for his class project, but his mother's car can only hold a 36-inch tall model. Which of the following scales is closest to the scale Jeff needs? So none of these answers are going to be exact because it's asking you which one is closest. But either way, I'm going to start by setting up that ratio. In this case, they're using inches to feet, so I'm going to do the same thing. The inches I know is 36, that's the tallest it can be. And the feet that I know is 1,450, because that's how tall the actual object is. And I need those to have a scale of one of those 4 options. Now when I look at these options, I see that the scale has 1 in the numerator of 3 of the 4 options. So what I'm going to do is I'm going to set this as a proportion where 1 is in my numerator, and hopefully this denominator will be close to either 25, 40, or 45. If it's not, I can go back and try with a numerator of 2 to see if this last option is right. So I'm going to start by doing this. I'm going to look at my cross products here, where I have 36 times x equals 1 times 1450, which means 36x equals 1450. And I'm going to divide by 36, solving this just like a one-step equation. And I have x equals, now I need to do this division. So I'm going to do that over here. 1450 divided by 36. 36 goes into 145 4 times, I would bet. I can try that over here. 144, perfect. And that gives me 1, 0. 36 goes into 10 0 times, and I am left with 10 36 as my fractional part. I can reduce that if I wanted to 5/18. And so my answer over here was that x equals 40 and 5/18. So my scale has a 1 in the numerator and 40 and 5/18 in the denominator. So which of these choices is that closer to? Clearly it's closest to B, so I'm going to choose that answer. In this last problem, I have a rectangular garden. The length and width have a ratio of 7:2, and I want to know if the width is 24, how long it is. So I'm comparing the length to width. The length is 7, the width is 2 in my ratio. Now I look at my width, which is 24, and the length is what I'm trying to find. Last time, I'm going to use my cross products here. 2x equals 7 times 24. 2x equals, that would be 28. 168 divided by 2. And I get x equals 84. So my 84 is how long it is, so that's feet. This garden, when it is 24 feet wide, it's 84 feet long.